Hey guys, welcome back to the channel. So we are solving the stack series, and one of the good question I found in solving and revising stack series is sum of subarray ranges. It's 2104 indeed codes. So what's question said? You have given an integer num and the range of subarray is defined as the difference between the maximum minus the largest value and the smallest value in a subarray. And you have to like in simple words for a given array you have a certain subarray from all subarray, just you have all subarray, and from each subarray the maximum value of that subarray and minimum value of this difference between maximum minimums, and add all from the all subarray. This is the sum of ranges. Like you have given nums 1 to 3, you have different subranges like 1 2 3. It's a sub a single element sub array. So for 1 it's the highest and lowest itself, so it's some range will be 1 minus 1, highest minus lowest is 1 minus 0, 2 minus 2 0, 3 minus 3 0. For 1 2 highest value is 2 and minimum 1, so 2 minus 1 is 1. For 1 2 3 highest 3, smallest 1, 3 minus 1 is 2. Okay, like that. So here I have to add all the ranges and return that. So how you approach this question? So one approach is simply, basically you all know the basic approach. But you know how to know the finding the subarray. Just while looking at the subarray, just find the maximum value in the subarray as minimum, and just subtract maximum minus minimum and add to the uh, sum, results. Add to the result and return the result. That's how you can generally solve. So it's concept code gonna order n square. Okay, so now it's time to have, when we have a much better solution, can we do actually a question, can we do a much better solution? Because sub-array problem can be solved with the finding sub-array. It's easy, but there must be a good solution. Absolutely there is a solution. So how it's, you all know in the previous question what is actually which actually we have done a question of the where we in the sub simply of sub-array you are finding the minimum elements. So how we done? Similarly, you has given array, you have finding the minimum from service array and adding them. So similarly, if you know, and if you know, if you have the minimum all the subarray and maximum of all that subarray, and just sum of the maximum minus sum of minimums, that's just your answer. Like how? For a given array, in the previous question that we have a logic of solving minimums of all subarrays. Some years written the summation of minimum all subarrays. Okay, so similarly, if you have summation of all the maximum subarrays and summation of maximum we minus summation of minimums, we have generally get the results. That what we want. So it's not a difficult. If you know the logic of the previous question, we have to do the summation of the minimums. You know the logic. Similarly, for the logic of minimums. Similarly, you have to make the logic for the maximum. Okay, and finding minimums, finding maximum, just subtract them and you have get the results. That's how you will. And the logic, it's we in the survey we found that particular element in the left side how much time, in the right side how much time it will occur, and we can multiply that. Left into right multiply gives us the total number of times it will in the subarray, and we then utilize with its value. Like it's for 3 it's 6, then we multiply by 3 and get the value. It is formula. Similarly, for the maximum, we check the left part of the time how many if this is a maximum, how much part of the left part of subarray it will be the part. In the right, how many time it will be the part. Similarly, we get total number of array for its the value is maximum of that element, and just into it value and we get that. So this is the logic you generally know. So not taking much time, the logic before. So suddenly we are solving this. Generally practicing not much. Actually, I got to a question today itself. So we have first words we need to make a stack. We made to make a stack. So just make it. Okay, not it out, and we need n equals to num size. Okay, surely. And first left part and first part we need two vectors, so just make two vector upside and first and last. It's actually, and this is how it's gonna. And then what we are solving, but then when we are solving for the first we are solving for the minimum part. Okay, Yes, you can make it good. Like you can make a function for solving the left minimum value first, and then go for the second highest value, finding maximum value in the subarray. You can do it, but yeah, solving in that function only. But it's a good practice to make two functions differently. It's a good way in doing coding or doing any things in for a company. It's a good practice to make a separate function for it. It's a good practice, but yeah, I'm just practicing revision, so I taught making functions so you can understand. Okay, so it's making for the first smallest value for the smallest value summation. So like what is the first 0 equals to what we one particle waste comes, and we can store a last also last and minus one. It's also come one time also. Okay, then what we have to done, we have to push in a stack that we're starting from that part 0, and we know that for loop now start from to 1 and I less than, and we are solving for the minimums in the left part. We are just finding the for the minimum left part. In the left part, how much time our element will come in a subarray when its value is minimum and that subarray. Okay, you know that's how it's solved. You know that when we check for the not stack empty condition first every time, so you know the logic. And also versus nums I, if nums I is smallest, now the current element is smallest than your stack top. Stack is gonna be getting, so it's finding the nums value. We will find in nums stack st dot top, because st dot top is generally containing your index. You can store the value, but it's good to have the indexes finally. Okay, if this is the case, just we have to pop till when we're getting the smallest value in the stack till the current one, like greatest sorry actually finding it when in the nums, if the is a stack dot top is in the stack, it's a greater value than the current value you do not need, so just stack dot top. Then you do that, then you have to find check if stack is empty. What that is mean, we already said. If stack is empty, that this is the smallest value till now in the subarray. So you first for this, what is equal to first for this is equal to I plus 1. I start from 0, that's why I plus 1. This time it comes in a subarray parts. Okay, and if not that empty, not st dot empty, what it means, it means the last part. This is not, this means, what this means, it is the smallest from the last part. Like current is the current where it comes, and st dot top is the smallest value. Okay, smallest value previous first previous smallest value it has been second is currently denoted like for if you are doing of the things. Okay, I is currently like of the things when you go through like something here, like there is something area of understanding for better. There is like you can think of like this 1 2. Okay, 1 to 1 you can say. So 1 to 1 you can say, so you can stack top if a stack dot top is 1, yes it's 2, but 2 for 2 you know stack dot top already has the smallest value. So 2 is not the smallest, 1 is the smallest. So for 2, how many times the left part, it's actually the I index is currently and the stack top index from that index. So I minus st dot top, that is what we are doing. Okay, I minus st top, and for the right part you do st top minus, because st top for greater index. Okay, that's why, and every time you have to push in the stack that index you are currently, because it can be smallest for someone also. So this is how we have solved the that part. And you know that after what you have to done, you have to just empty the stack. You are not making the different stack, so just do that. While not stack empty, just st dot pop, or you can make a new stack to also, it's your choice. So now it's traversing for the right part. So first we have to push from the right n minus 1, you know, just copy this. No, just copy this. Yes, start from here n minus 1, n minus 2 actually, because n minus 3 and 2, and I greater than equals to 0 and I minus 1. There is a condition equals to is also added, because you know we are starting from the right side, So if the equal value, like there is 3, there is also 3, so it means this 3 is come first, so that's why the previous 3 in the store will be removed too. That's why we have done equals to here, not in the left word, because left word we are moving forward, so first is always first smallest equal values come first. But right part, it may be like we are getting the same value in the top, but currently in the from the moving to the left we also get the smallest, but actually if you see the summary, it's the left, the part will current that it will be the smallest first come, so this value is come first. That's why we are moving actually. And here last is not I plus 1, actually is from ending, so n minus I actually. And I know that st dot top is greater than I, so we just st dot top minus I we do. You know that code, okay, there's nothing changes in that code. Logic you know for the greater element only, okay. Then you do this, you know. Now you have to find what actually you have to find actually the value means. So just make a long sum you make for you can define min sum for int I equals to 0, I less than, and I plus plus actually. And what's the scope? Scope till like you have log now prod make a product, because you have a total number of arrays, but first of that I into last of that array, or also into it gives you first and last, it gives you total number, and we should multiply with the current value also, because we need that value actually. So what's this num psi? That's how. There's no need of mod, so I'm not doing mod here. In the previous question we do, because they are required. So now just we have to add this into the our min sum plus equals to prod. Here I missed the value return, but yeah, prod. Now we have done this. Now we have similarly do for the right part. Similarly we have to do that for the right part. So just do this code copy first. Actually make a function, actually it's good practice. I'm not doing this for the reason, that's why, but it's good to have make a function. Yeah, so it's good. Or yes, we have to like also stack empty also here. And we are just finding the max now. So first see this case is right. Now first the condition changes that only. Now if you are from the left to the right for the maximum, like when we come 2, so 2 is greater than 1, so 2 is greater than 1, so the condition nums I is greater than num stack dot 2. Just if this is the case, just pop, because we are not finding the maximum. Now 2 is greater than current is greater than the previous st dot top, so you have to remove from the state. This is only the change here, okay. And similarly this is the thing, same goes on. And for the right part too, where is it's actually greater than equals to, you know, because like it's 3 is there, 3 is also there, so first 3 come. But if there is 3 already with current line 3 also there, it means this 3 will become first. So equal to also case st dot pop will do similarly like in the neon case from traversing right to left, okay. And but yes, greater than condition will change like before. For that we are finding the greatest value, this is only the change. All things remain same, okay. Now just have to find the maximum here. Now maximum, this is the long maximum. And just once again you do to I equals to 0, I less than, and I plus plus, and yes, long prod again. What do you make and what's it's and what you do first off, similarly like finding the same things. First u minus into, sorry, last I, and the value we have to add on, so it's num psi, and we have to add in on maximum plus equals to prod. That's how it gone. Just at the last we have to return what we have to return, you know, max sum, because it's contain the sum of all the maximum in the subarrays. and minus means sum. It contains the minimums of all the subarray. Just run it. Okay, mistake first. Okay. We have to check here also because we have to beat this 2 here. Okay. All things will be similar. Stop actually. Doing the first code can be sometimes given a lot of mistakes, so you have to things correctly. It's not pop, it's stop. Start top, pop is there, it's correct. St dot top minus I and stop also here. Let's run again. Takes 928. Where is equals to? Lot of common mistake I've done, so you have to take care of this also. Sometimes yes, I'm just fast driving, doing fastly, so it can you have to take care of that. Whereas test cases are submitted. Let's check it. Yeah, the solution is accepted. It's not a mistake. It's actually we are multiplying 3 times at a time, so it's getting out of range maybe. So I have just shifted this only. That's work. So maybe so that I'm complexity for this, and times years and so something if overall you can in complexity order of n, and yeah, solution also is space order of n also. So overall, it's good than previous solution of severing, finding severance and minimum maximum there. So it can be n square, but it's odd one, so it's a good solution. It's a good question to done, and so we have done a good, really good question and have a good practice. A lot of mistakes but it's like a pretty messy here. So I always say make a different function for like finding for the minimums and maximum. It's a good practice. Actually, it's a good practice. It's not a good here like it's looking a lot of messy, so I just want to say you do that making one. It's just a practice, that's why I do it at the same time for making that, but making efficient with efficient codes, it's good. Have a good and ready codes will also have a point, so you have to do it. Okay, thank you guys.